Finally, an end-fed half-wave antenna that I'm really happy about, and I'm excited about this. So that's what we're going to talk about in today's video. Welcome back for another video. I'm Yankee Oscar 6 Delta X-Ray Echo, and a month ago I presented a video of my end-fed half-wave antenna that I wanted to test using a 49:1 impedance transformer built on this tiny toroid. You can go back to that video and watch it if you want. I'll put a link down in the video description. But it's supposed to be very efficient, and no doubt that it might be. I was happy about it. It works well, but I had a couple of issues, and we'll talk about those just a little bit later. So I decided to rebuild my 49:1 impedance transformer. I rebuilt my RF choke and so on, but I went back to a system, to something that it worked really well for me 3 years ago, when I was in my older QTH, and I decided to recreate that and see how well it performs right now. Why it will be different? Well, we'll talk about that in a second when I'm going to talk about the impedance transformer. But I'm looking forward for better results than the ones that I had with the tiny 49:1 impedance transformer, which, by the way, I'm still going to keep. I'm going to put this one in a smaller enclosure, and I'll keep that for portable work if I want to pack something really, really light, and I think this will do. So let's talk about the transformer that I just built right now. This is the impedance transformer that I remade using a FT140-43. I had this one before in my older QTH, and it was performing really well. So I decided to rebuild it just because I wasn't that happy with this smaller version that I built some while ago. You have the older video that I posted probably a month ago. It still works fine. I'm just not as happy with the SWR. And I noticed a couple of things, but we'll talk about those as soon as I finished installing this one, because it's getting dark outside and I want to go install it so I can do the measurements together with you, and we'll see the differences in SWR. According to the table that I found online, most of the bands have the efficiency of the impedance transformer somewhere around 85%, if you look on the screen right now, except the 80 meters band, which is not that good, but still I'm not spending that much time on the 80 meters band anyway, so at least if I get to use it, I use it locally most of the time, so I'm fine with that. And probably if I'm going to use the 80 meters band or the 160 meters band for some performance stuff, definitely I might have a dedicated antenna for that matter. So right now I'm just happy with this one. Not sure how well it will perform, but I'm really curious, just because in my older QTH the antenna used to be a lot higher. It was somewhere around 6 meters high above the ground, and right now it's like half of that distance. It's somewhere around 2 meters 50, 2 meters 80 centimeters, something like that. So definitely it probably won't perform so well on the 40 meters band, but we'll see. I will check the SWR. So let me go outside and install it, and after that I'll be back so we can do some measurements. But the way I built it, by the way, is just the same as I built this one in the last video. 3 turns primary and 21 turns total. So yeah, that's the way I built it. So it's nothing different comparing to the other one. It's just the toroid that I changed. I kept the same capacitor, 100 picofarads. So yeah, let's see how it performs. If you're like me and you like working on your projects and designing your own PCB boards, don't forget that we have PCB Way on our side. They have great PCB prototyping services, PCB assembly, SMD stencils, CNC, and a lot more available for you. All you have to do is to design your PCB board, upload the Gerber files to the PCB Way website, get a quote depending on the PCB board size and the options that you picked, and place your order. And after that, all you have to do is to wait for the order to arrive so you can build your project and you'll end up with some good quality stuff. Now, if you don't have an account for PCB Way, have a look down in the video description because you'll find a link where you can register for a new account and you'll get a discount on your first order. As I'm always saying, PCB Way is the way. Before we do the SWR measurements, I also wanted to mention that I also replaced my RF choke. If you remember in the last video, I had the RF choke which was made with coax cable around the toroid. This is the older version that I used to have, so I've remade it simply because I noticed that the coax version, it was slightly changing my SWR, yeah, I've been testing both versions. I didn't film the whole thing, but I will show you right now that when I'm placing this RF choke, the SWR is very similar to what I have if I'm not using the RF choke. So that was the very important factor for me, even though I didn't want more connectors on the line just to avoid losses, but it is what it is. I prefer to have a clean SWR just as it comes from the antenna itself. So there's an older video, I believe, that I made in the past about I explained more about the way I build the RF choke. I will link it down below in the video, and I'll also put a link to the last video about the antenna that I made using this toroid over here, the tiny one. So yeah, anyway, let's carry on with the SWR measurements really quick. So these are the SWR readings that I have right now. Trying not to move too much the nano VNA. But let's go a little bit closer. So I'm going to go stimulus, start 7 megahertz and stop 7.2 megahertz. And somewhere around 7.2 I have 1.7 SWR, and if I go a little bit lower, all the way down to 7 megahertz, it goes down to 1.5. And if I go even lower, let's go to 6.5 megahertz, you'll see that I have a dip here somewhere around 7 megahertz. So probably I have to adjust the antenna wire, which I cannot adjust right now just because it's kind of short, and what I'm trying to do is to replace the cable with a different one, and we'll talk in a little about that detail and why I want to do that. But anyhow, I'm happy. 1.5 over here, it's pretty good. If I go to 7.1 megahertz, and if I get that 1.5 as well over here, 1.6 is pretty good, and it's enough for me. If I would have the antenna a lot higher, like I used to do my older QTH, around 6 meters high, I remember back then the SWR was nearly 1.1 to 1, so it was much better. Let's go to the 20 meters band right now. I'm going to go 13.5 megahertz and stop 15 megahertz just because I want to show you something. So over here I have a dip somewhere around 14.2 megahertz, and the SWR is 1.4. I might have to adjust again the antenna, and probably if I adjust it for the 40 meters band, this SWR might get a little bit better, somewhere around 1.3 to 1. That's what I used to have in the past. So anyhow, the antenna still performs really nice on the 20 meters band. Right now I'll go to 21 megahertz really quick. Stop, I'll put 22 megahertz just for fun and to move fast. And here I have a dip somewhere around 21.5 megahertz. So again, I will have to make some adjustments on the antenna wire, on the length, but look at the SWR over here. It's 1.0 to 1, so it's really nice. Yeah, I'm glad that it works fine. So I'll start again with 28 megahertz and I'll go to 30 megahertz stop. And here I have a dip somewhere around, but for the 10 meters band I might need to use an antenna tuner if I want to use the entire portion of the band. Here the lowest, it's 1.5, 1.4, somewhere around there. So anyhow, it's way better than, I think, than what I had with the other one, with the tiny impedance transformer. Not big differences, but it's slightly better. So I'm glad with the results that I have right now, and I'm pretty sure if I put the antenna a little bit higher, I will definitely have better results. Oh, I wanted to show you something really quick as well, because I was talking about the RF choke. So here's the SWR on the 40 meters band with the RF choke in line, and right now I'm just going to remove the cable and bring the coax cable straight from the antenna and connect it. Sorry for the noise, trying to pull the cable over here, and I'm going to connect it again to the nano VNA, and as you can tell, the SWR didn't change as much. It's just slightly higher. Over here it resonates right now somewhere around 7.05 megahertz, sorry. But with the coax version, it was changing everything. Like it was going really, really low. Sorry, like it was moving the SWR somewhere around 6.5 megahertz. So I had to readjust the antenna, and you know, like it was annoying. So I had the same issue when I was using the vertical, the 20 meters band vertical antenna. If I used it without the RF choke, I had one SWR reading. As soon as I put the RF choke, it would change it a lot more, so I didn't like that. And yeah, right now let me plug it back in if I can. I have to put the cable back into the hole over here, which you can't see, but I'm trying to. And then I'm going to connect everything again. And here we are. The SWR is nearly the same. So it didn't change much. And this is the part that I like very much. Anyway, let's talk really quick about the antenna wire. So I had a lot of discussions when it comes to antenna wire with my friend Yankee Oscar 6 Tango Tango about using silver-plated copper wire, which technically it should improve the performance at least a little bit, especially on reception. But I do remember that when I was a kid, my grandfather always used to tell me, for some reason, he knew something probably, that he has to replace his antenna wire, the one for the crystal radio that he had, with silver-plated copper wire, not just a regular copper wire. So I'm curious. You never know until you test it, so that's what I'm going to do. This one is a little bit thin and it's very short. It's only 4 meters long. But I found a store that sells enamel copper wire, silver copper wire that it's used for jewelries and stuff, and I want to buy it from there because it's not that expensive. So I'll test it and I'll let you know to see if I see any noticeable differences. But I'm really curious. I don't know. Have you guys tested this? Because I never tried this for any antenna. I never used silver-plated copper wire to see if it improves performance. So let me know down in the comments if you tried this before and if you realized, if you noticed any differences. But that's the idea. That's what I'm trying to do. And most probably for the next step, I'm also going to build the 110 microhenries inductor to place at the end of the antenna to extend it a little bit, and also this way I'm also able to use the 80 meters band. So last night overnight, while I went to bed, I also left the transceiver to transmit. It was the QRP guys digital transceiver that I recently finished building. So it transmitted all night long, and these are the results. You can see it on the screen right now. I was really happy. I will test it this couple of days, only that I'm a little bit busy, so probably next week I will have more time for radio, because right now I'm extremely busy. But I will test it on SSB and see the results and the performance of the antenna much better this way. So yeah, so far it performs really well. I'll try to see it tonight if I have any free time, but I doubt. Maybe I can try some SSB contacts and some FT8 just out of curiosity to see the differences compared to the other impedance transformer. But of course it all depends on the propagation as well, because you know propagation conditions might be different compared to what I had when I was testing the other impedance transformer. Well, my friends, I hope you enjoyed today's video. It wasn't as long as the last two that I posted, so I hope that's better, because I tried to keep it short. I just wanted to do this quick update and let you know about the differences that I found between the impedance transformers and how the antenna performs, just in case you might have similar issues. So hopefully it might help you as well to figure out things, you know. So that's it for today. I'll wait for you next week for another video. Until then, thanks so much for watching, and 73 from Yankee Oscar 6 Delta X-Ray Echo.